Good afternoon, ladies and gentlemen. Welcome back. Today we're going to be jumping into chapter 10.4, and we're going to be looking at surface areas of prisms and cylinders. Chapter 10.4 relies on knowledge of 10.1 and 10.2, so if you haven't seen those yet, please check those out on drawing some 3D figures and doing nets of the figures. Those are going to be especially helpful. A couple of terms. First off, you know what bases are. Right prism is a prism that goes straight up and down. Similarly, a right cylinder is one that goes straight up and down instead of being slanted. Think of it as a stack of CDs versus a stack of CDs that has been tilted slightly. Lateral faces, we've talked about lateral things being on the side. Every single prism, every single cylinder has a lateral surface or a set of lateral faces. There are a few terms that we're going to use for each of these figures. Lateral area, base area, and then total surface area. All right. So let's start with the net of this figure. This one is a triangular prism. If we draw the net of this figure, well, it's a triangle that comes down kind of like that. It has a rectangle between a couple of triangles. Something like that. Another triangle. Then, so that covers that rectangle, triangle, triangle. We've covered those. And then we have a couple of larger rectangles coming out of either side. Right here we have a rectangle coming out of this side. It's probably not quite that tall. Here we go. And another rectangle on this side. All right. So 3 different rectangles. Looking at a few of the dimensions here, I noticed that the width of this first rectangle is 10. That means the width of all of these rectangles are going to be 10. We have 10 from the top to the bottom. All right. Also notice that we know a few of the distances. We know this one here is a 15 from right there. We know one side's a 17. What else do we know? We know that the triangle on the back here is a 15. We don't yet know this side, this bottom portion right here. So I'm going to go and do a quick Pythagorean theorem. We don't know that side. We'll call it x. X squared plus 15 squared is 17 squared. X squared plus 15 squared is 17 squared. Put in my squareds. If we go and solve this down, I'm going to go and just plug this into a calculator here. 17 squared is a 289. Subtract 15 squared, which 15 squared is 225. 289 minus 225 gives us a 64. So we'd say that x squared is equal to a 64. If you're having trouble with this portion, please look back to chapter 5. Chapter 5 on Pythagorean theorem. That would really help you out. So x has to be 8. All right, x has to be 8. That means this side right here is an 8. Now, lateral area is not too bad. We have a rectangle. Looking at this overall blue rectangle right here, it looks like it is a 10 by a 15 plus 8 plus 17. 15 plus 8 plus 17. 15 plus an 8 plus a 17 gives us a 40. So it's a 10 by a 40. So that's a 400 inch squared surface area. All right, that's our surface area. Base area, we're going to look at just one single base. And we'll do the standard equation, base times height times a half. 1/2 base times height for triangles. So base area, we'll call it capital B. By the way, this lateral area, we'll call that capital L. Base area, capital B, is going to be 1/2, so 0.5 times an 8 times a 15. 8 times 15 and divide that by a 2 gives us a 60. We'd say that the base area here is a 60. All right, base area here is a 60. So overall surface area now, I'll go ahead and write that in orange here. That's going to be the total lateral area. We'll say surface area, S, is equal to lateral area plus a couple of bases because we have base on top, base on bottom. So we could say that's 400 plus 2 times a 60. 2 times a 60 is 120. 400 plus 120, that's going to give us a total surface area. 400 plus 120 will give us a 520 inch squared surface area. That's the area around the whole figure. Looking at this next shape here, we have a cylinder. A cylinder has a pretty decent, pretty easy surface area. It's going to have circular bases. Awesome. It also has a rectangular lateral surface. The lateral surface is going to look something like that. Remember, if you've ever rolled up or unrolled a label off of a can, you might have noticed that it forms a rectangle when you unroll that. Each of these circles has a radius of, well, the whole thing's 16, radius of 8. Draw in 8 here, radius of 8. I notice that this has a height of 10. The question, though, is how wide is this rectangle? Well, since the rectangle did wrap all the way around the circle, well, all the way around a circle is a circumference, we can just use circumference formula. Circumference equals pi times diameter. So that's pi times 16. Plugging that into my calculator, 3.1415 times 16. 16 multiplied by a pi gives us approximately 50.27. All right, 50.27. That means that this whole distance from here over to the other side is a 50.27. Looking at the lateral area, well, the lateral surface is just the rectangle. That's 10 times 50.27. So anything times 10 is going to move the decimal over 1. This is 502.7 inches squared for our lateral area. I can rewrite that a little better. Lateral area equals 502.7. Base area, I'm going to go ahead and write that in red. Base area is always just pi r squared, pi times 8 squared. Plugging that into my calculator, I know 8 squared is 64, so 64 times a pi is a 201.06. Base area is 201.06. So getting those all together, I'll switch over to some blue for surface area. Surface area is equal to our lateral area plus a couple of bases, since there are 2 bases. So that's going to be 502.7 plus 2 times 201.06. I'll tack on the 201.06, so multiply that by 2. Add on a 502.7. That leaves us with a total surface area of 904.8 or so inches squared would be our final answer for the surface area of a cone, or a cylinder rather. Surface area of a cylinder like that. Last shape that we have here today, general equations, you can save a little bit of time with lateral area. If you just do 2 times pi times r, or pi times d, you can take the pi times d and then multiply that by the height. All right, for lateral area, that's what we did. Surface area, you can just do pi times r squared, and then add on the pi times d times h as well. That would be a surface area equation for a cylinder. All right. So if you wanted to use those equations then for this cylinder, let's say, lateral area, well, we'll do pi times diameter of 28, since it's 14 times 2, diameter 28, times our height of 9. That gives us a lateral area of, plugging into my calculator, 28 times a 9 times a pi. Gives us 791.7 for our lateral area. Surface area, remember we said pi times r squared, and then we'll add on the lateral area. So we'll go ahead and do pi times 14 squared. And we'll add on 791.7, tossing that all into my calculator here, plus 14 squared times a pi is all equal to an overall 1,407.4 centimeters squared would be our overall surface area using those formulas. For the last problem up here today, lateral area, base area, surface area of a hexagonal prism. There are several pieces to examine here. I know this is one that several of you did as an extra credit opportunity a little earlier on in the year. If you did that already, my congratulations go out to you. Nicely done. But not everyone got it right, so let's go ahead and look at it here. We do have a hexagon, so 6 sides. 1, 2, 3, 4. I'm making an octagon, excuse me, a hexagon. 1, 2, 3, 4, 5, 6. Though the drawing is terrible, assume this is a right or a regular hexagon. We have a bunch of rectangles. 1, 2, 3, 4, 5, and 6. These rectangles should all be the same size. My apologies that they are not. It's hard to draw with a computer. Last couple of sides here, we have another hexagon going on. 1, 2, 3, 4, 5, and then 6 for the original side. Here's our net. I know that the distance here is 10 for the height of each of these. All right, my mistake. These should be 10 on each of these sides if we rolled it back up. A 10 right there, a 10 right there, a 10 right there, a 10 right there, a 10 right there. No, I'm doing this wrong. Excuse me. Excuse me. Let's go and cross this out. I was right the first time. Height of this is going to be a 10. The sides of each of these hexagons, they're all 6. So we have a 6 right there, 6 right there, etc. That would make each of these a 6 instead, not a 10, a 6 instead. Excuse that. I don't usually make mistakes. All right, so a 6 on each side. Excellent. If you want to find the lateral area, well, overall we have a large rectangle that is a 10 by a 6 sixes, so 36. That's a 10 by a 36. We'd say that the lateral area is 360 units. We could say that's meters squared, 630 or 360 meters squared for the lateral area. Now we need to look at the hexagon specifically. Base area, if you remember, of a hexagon, we need to start drawing in some of these apophthegms and angles and whatnot. We split this all up into pieces. You might remember to get these angles, 360 divided by 6. If you're having trouble with this, look back to section 9.0 I want to say it's 9.4 or so, somewhere around there, 9.3, 9.4 on areas of circulars and regular polygons. Each of these angles is going to be a 30. All right. Each of those angles is a 30. We know that the perimeter is 36 already. We need to find the apothem. So we can go ahead and say, well, this angle right here is 30. It was opposite of 3, apothem of who knows what. We'll use tangent of 30. I'm going to go and write that down here. Tan of 30 is equal to opposite 3 over apothem A. That means that if we flip a couple of these around, because we can do that if they're being cross-multiplied, we can flip these two pieces around. We could say that the apothem is really just 3 over tan of 30. Tossing that into my calculator, 3 over tan 30. Divided by 30 tangent of that. That gives us a 5.19, about a 5.2. All right. So apothem is about a 5.2. That means that the area, the base area, is 1/2, so 0.5 times perimeter, 36, times apothem, 5.2. If we multiply those all out, times 36 times a 0.5, that gives us about a 93.53. 93.53. Surface area then. I'm going to go ahead and switch over to some orange for surface area. Surface area is going to be equal to our lateral area plus a couple of bases worth. So I'm just going to verbally say this here. That'd be a 360 plus 2 times 93.53. 2 times 93.53. That's going to give us a grand total of 547.06 meters squared. Is our grand total answer. There's our surface area. If you have any questions, as always, shoot me an email. Let me know. Otherwise, have a delightful day. Homework is in your book, I believe. Check it out on the homework calendar. Take care.